Did we complete CNN? Yes. Yeah. So today I'll be starting with NLP pre-processing techniques I'll explain, and we'll do some projects related to NLP as well. Just a minute, let me share my screen. Sorry. Just check, can you see my screen? Okay. So basically, what comes to your mind when I say NLP? So when I say NLP, NLP stands for Natural Language Processing. Natural language processing. And the second important thing, we all know that when it comes to a machine learning, we were dealing with a data which was present in a table format. And ML was used to make a prediction based on whatever data was given in a table, and it used to learn and it was making a predictions, right? So now, next important thing, we studied about a deep learning, wherein we dealt with images. So when I say images, like we need to understand the features of images. So we used a convolution and then we made a predictions, right? So now this is images. The next important thing, what if you have a document kind of thing, or what if you have a text data? So in order to deal such data, we use a concept called as an NLP. Okay, NLP is natural language processing. NLP is used to handle text data. Okay, when I say text data, what all things it can do? Let's say, for example, email classification. Well, you might ask me, can we use machine learning for this? Yeah, but you know, NLP thing works better. So when it comes to an email classification, usually emails will be like bit longer, right? It will be lengthy. So in that case, in order to predict whether a given email is ham or a spam, we just use a concept called as NLP techniques. Sentiment analysis. Let's say, for example, you have a movie reviews wherein you want to classify. Let's say if somebody says like movie is good, it has to classify it like a sentiment as a positive sentiment, positive review. Coming to a negative, if somebody sees like the movie was boring or it was so disappointing watching that movie, so you can see certain negative words, so it classifies like a negative review. So that's a sentiment analysis, positive, negative, and advancement towards this NLP, summarizing a document or creating Q&A chatbot, extracting content from an images. All these things are basically possible with the help of your generative AI that I'll discuss at the end of your probably this month. Okay. So this is NLP. I hope you got it. So whenever you deal with that text data, we all know that even when it comes to a machine learning, so text alone cannot be passed to the model, right? We need to convert that into a numbers. So how do you do it? So that's the reason you should have a knowledge of NLP pre-processing. A very important topic, very important questions usually you get in interviews related to text cleaning. So when I say NLP pre-processing, we have a different methods which are basically used to clean data. So first thing you can clean data. Second thing you can convert text to a numbers using different formats. So far we learned only encoding techniques like label encoder, one hot encoder, manual encoder. But here when you have a lengthy text, so we have a different ways to do that. Okay, it helps you in converting text to numbers. Okay, so now, so we'll discuss about different cleaning techniques that basically we have. We will be using two libraries. One is NLTK and a Spacie. They are the two things which basically helps you in cleaning your text. Okay, there are certain things which could be done with the help of NLP pre-processing from interview perspective as well as from a project perspective. So you need to master a few things and also you need to understand few things. Okay, let me explain them. Just a minute. Any idea what are the different cleaning things that we do whenever you take up a text? The first level of cleaning, what do we do under first level of cleaning? So first we'll start with our basic cleaning. What are the basic cleaning that are performed? So when I say text, don't you think all the text will be in a mixed cases? Mixed cases in the sense. A very first step, whenever you have a date kind of stuff, it's important to convert all the text into a lowercase. Okay, that's the first important thing. We need to convert all the text into a lowercase. Convert lowercase. Second thing. So once you convert text to a lowercase, what you will do? You have to remove all HTML tags. You know HTML tags, right? URLs, special characters. Sometimes certain special characters are important, like exclamatory question mark kind of thing. And the next important one is URL special character will be removing punctuations as well. You know punctuations, no? Full stop, comma, brackets. Everything should be removed. And also, you can remove certain emojis and what? White spaces. White spaces in the sense you know, right? Like extra spaces available. White spaces in the sense extra spaces available. So that's a basic cleaning that you perform. The next important thing, you need to perform a tokenization. Any idea what is tokenization? Very important interview concept, very important concept in NLP as well. So what is tokenization? So when I say tokenization, it's a process of breaking text into a smaller and smaller units or a chunks. We call it like a tokens. Okay, so it's a process of breaking text into smaller and smaller chunks. Smaller and smaller chunks, usually we call it like a tokens. Okay, when I say tokens, so you have a different types of tokenization. One is a word tokenization. Another one is sentence tokenization. What is word tokenization? What is sentence tokenization?
Splitting the sentences into individual words is word tokenization.
Hmm. If I say I have a sentence like I like NLP, so it just splits everything into a list of words like this. Okay, when it comes to a sentence tokenization, let's say you have a paragraph. It's like Python is hard and SQL is easy. So what will happen in this case? So first sentence is going to be Python is hard and then SQL is easy. Yeah, understood. That's a tokenization. Next one. Any idea what are stop words? Have you heard about the stop words? Stop words.
Like they don't add much meaning to the sentences.
Hmm. So they are just like connecting words.
Yes,
Yes,
ma'am.
ma'am. Like, yes, it's yeah, is
I
the and
like, yeah, is, yes. So stop words are basically, they're just like a connecting words, common words, I would say. Stop words are basically a common words, such as, there are so many, but I'm just listing few like is, the, a, by, and. Okay, all these things basically stop words. That doesn't add much meaning. They're just like connecting words. They themselves don't have any meaning, right? Doesn't have meaning. Just to make a sentence meaningful, they are like a connecting words which are used. Okay. So very important thing whenever you have a sentence, let's say for example, I'll say like I'm the principal of college. So what are the stop words in this case? If I remove stop words, like what it will remain, what it will retain. Remove all connecting words. What will remain if I try to remove everything? I is a stop word, am is a stop word, the is a stop word, of is a stop word. Only meaningful, important words are principal and the college. Here, understood. That's a stop word. Next one. Shall I proceed? Tell me what is stemming. Tell me what is stemming.
Reducing the words to their base form.
Yeah. So stemming basically reduces words to their root form or a base form, one and the same. So what do you mean by that? Let's say, for example, if we use a stemming concept, you have a word like a playing. So when I say playing, when I say caring, when I say studies, so can you tell me what would be the stop words? So I mean stemming. So usually stemming, what it will do, it just reduce it to the root form or a base form. But how it does, just by it just trim out the suffixes or a prefixes so that it reduces to the root form. So for playing, what happens? It will be play. For caring, if it is cutting off ing, it will be like a car. For studies, if it is cutting off es, it will be like a study. So now play has a meaning according to English. So caring car, it's not making sense. Studies and study, this word is not available in our dictionary. So what is the limitation of a stemming then? Stemming cut down words to their root form, but it doesn't give you the proper meaning. The root form doesn't make sense, or it's not meaningful context. Okay, that's one of the limitation of a stemming. So root forms are not meaningful. So study doesn't make sense. It doesn't have any meaning in English. Hope you are getting, right? Yeah. So how to overcome this? So we have a concept called as lemmatization. We have a concept called as lemmatization. So what is lemmatization? What happens with this? What happens with lemmatization? So to overcome limitation of a stemming, lemmatization is used. Again, it overcomes stemming limitation by converting words to their root form using grammar and a context. Okay, by converting words to their root form using grammar and context. Okay, it uses the concept of grammar, and accordingly, grammatically, the valid root form will be given by this lemmatization. So comparatively, people can ask a difference between stemming and lemmatization. Even both does the same thing. Stemming doesn't give you the meaningful root forms, but lemmatization does. So comparatively, lemmatization is the best option compared to your stemming. Got it? Understood. So let's say, for example, you have words something like this. You have a studies. So it's basically a verb, right? Studies is a verb. It will understand the verb, I mean, grammatical context, and then it gives you the root form, which is study, which is meaningful. Study makes sense compared to studi, right? And similarly for better. So better is adjective. So it just gives you root form like a good. So going is also a verb, right? Activity. So it gives like a go. This is related to a lemmatization. Understood. Is it clear? Any questions you can ask? Done? Okay. So next one, next important thing. POS tagging. You know what is POS tagging?
Parts of speech.
So POS basically stands for parts of speech. It's like understanding grammar. So parts of speech tagging. So basically what happens in this case, it identifies the grammatical role of words, whether they are noun, verbs, or adjective. Okay. So basically it identifies grammatical role of words. Like whether they are noun, verb, or adjective, etc. Adjective, etc. Let's say, for example, so with this knowledge, it basically helps you in understanding the word context or the meaning in a better way. Sorry. So we have a cat, we have a sat, and then we have a better. Can you tell me the corresponding part of speech for this?
Cat is a noun. Sat would be verb and better is adjective.
Yeah, good. So cat is noun, sat is activity, so verb, better is an adjective. Okay, this is how the tagging is going to happen with a POS. That is a part of speech tagging. Hope it's clear. All good so far? All these are very important for interview perspective. So next one. What is NER? Claudia?
No, ma'am.
So NER in the sense it's a named entity relationship. NER in the sense it's a named entity relationship. Okay. So what it will do, it's one of the pre-processing technique which identifies the real world entities in our text. Okay, it just identifies real world entities in our text. What do you mean by that? So it's like identifying if it's a place name, identifies like a place. If it's like a person name, it identifies like a person name, person or a name. If it's a location, it says like a place or a location. For a job role, it says like a designation, something like that. Okay. Let's say, for example, you have so Narendra Modi is the Prime Minister of India. So what it will do, it recognizes Narendra Modi as a name, Prime Minister as the designation, and India will be location. Okay, that's how named entity relationship is going to work. It helps you in recognizing the real entities. It helps you in recognizing the real entities. Clear about NER?
Yes, ma'am.
Okay. One hot encoding already even that's a part of it. So basically, what happens one hot encoding when you have a text? Same process. It creates a new columns, no? So represents, converts text to numbers or represents text in number format. Okay, let's say for example, I have a word like I have a sentence like I like Python. And then Python is easy. Okay, let's say it removes all the stop words. Will be just left with what? Python and easy, right? So basically what happens? So it will see wherever you have a Python, it will be 1, 0, 0, 1, something like this. Okay. So let's say this is first sentence and let's take this as second sentence. So I like Python, one more is Python is easy. So with sentence 1, so Python is there, 1, easy is not there, 0. For sentence 2, Python is, oh again we have a Python here, sorry. So we have both Python as well as a easy, so it will be 1, 1, like this. This is how one hot encoding works with our different sentences. With different sentences. I hope it's clear. Next one. We have a concept called as a bag of words. You know what is bag of words? What bag of words will do? So bag of words basically counts how many times each word is appearing in a sentence. Okay. Bag of words counts how many times each word appeared in a sentence.
Hello? Hello?
How many times each word appeared in a sentence. Kids are listening to my class. Okay, let's say for example, if you have an example like I think it was easy. SQL is easy. So what will happen? Bag of words will be finding count of the words are going to be Python, easy, SQL, right? So bag of words are going to be Python repeated one time, easy twice, SQL one time. It just find the frequency of or the count of a particular word, like how many times it has appeared or how many times it has repeated. Okay. Done. This is all related to bag of words. If it's done, next one. So we have a concept called as n-gram. You know what is n-gram? Just wait. We'll just take a short break and then we'll discuss. 10:07 now. Take it till 10:15. And then I'll discuss what is n-gram and also TF-IDF. And then we'll do the implementation of all these using a library. Okay. Take a break. You people are back. What is n-gram? What is n-gram? So basically, when I say n-gram, it's all about, how many words it select at a time. You have it like a unigram, bigram, trigram. Okay. So n-gram is basically contiguous sequence of n items in a sequence, sentence. So contiguous sequence of n items. So what do you mean by that? So we have a different grams, okay, like unigram. So when I say unigram, you take each word at a time. Okay, sentence is getting divided into single words. When I say bigram, two words at a time. Okay. And then we have a trigram where it will be like a three words at a time. At a time. Clear? Understood what is n-gram?
Yes, ma'am.
You'll understand better when I show implementation. I'll show it. One more important thing, the last topic, TF-IDF. You know what is TF-IDF? A very important concept. TF-IDF. Even it's a process of converting text to numbers. A very important process of converting text to numbers. So how it converts? In this, you need to understand the two things. First one is a TF. You know what is TF? No? TF in the sense it's a term frequency. Okay. TF is term frequency. So, and this term frequency is calculated using a formula. Number of times the word is repeated divided by total words in a sentence. Okay, that's a term frequency. This is a formula. Let's say you have three sentences. I'll show how it works. For sentences, Python is easy. Then SQL is hard. And then Both SQL and Python are easy. Okay. So I'm taking these sentences. So basically what happens? I need to remove the stopwords. So if you remove the stopwords, what happens? So we'll be just left with Python and just an easy. And then you'll be left with SQL and hard. In a sentence 3, you'll be just left with SQL, Python, easy. Right? Okay. So now you need to calculate a term frequency. How do you calculate? So it will take a words, okay? So what are the unique words we have? We have a Python. We have SQL. Easy and hard. These are the unique words. Yeah. Okay, how many sentences we have? 3 sentences now. So sentence 1, sentence 2, sentence 3. Now use the formula and tell me what should be the values. Look into the formula. According to formula, number of times the word is repeated in a sentence by total words in a sentence. See how many times Python you have in first sentence. 3 times, just 1 time now. How many words?
1/2.
Yeah, 1/2. Second sentence? 0. Third sentence? 1/3. Same with SQL. First sentence not there, 0. Second sentence 1/2.
1/2.
Third sentence
1/3.
Yeah, good. Easy.
1/2. 0. 1/3.
Yeah. But hard? 0. 1/2.
1/2. 0.
0. Oh, hard is not there. Okay. Good. So this is how term frequency is going to work. I hope it's clear. It uses a formula. We need not do it, but what if people ask you like how it works? You should be able to explain it. Okay. So this is term frequency, but it's T of IDF. So now you should know what is IDF. What is IDF? IDF is inverse document frequency. So what is this inverse document frequency and how it's going to work? How this inverse document frequency is going to work?
It will measure the importance of the word across multiple documents.
Okay. Yeah. So this IDF is basically calculated using a formula. IDF equals, it just uses a log, number of sentence, divided by number of sentences containing that word. So as she said, like it's finding the importance of each word across different sentences. Number of sentences containing word. That is IDF. So what will happen to the same, like, first let's see, we'll find the IDF and then you just need to multiply each TF with the IDF value. That's a TF IDF. Okay. You want to find inverse document frequency of a Python. How important Python across all different sentences. So if you want a definition, it finds how important the word across sentences. Okay, so now you have to find IDF of all the words. So first let's find IDF of Python. So which is, what will be the IDF of Python? How many sentences we have?
3.
So total 3 sentences and number of sentences containing that word. 1, 2 now. So it's log 3/2. Here, then it's IDF of SQL. Same. 3 sentences. SQL is present in 2 sentences. So what is IDF of easy and what is IDF of hard? Easy present in how many sentences? Just one now. Hard present, no. Easy present in 2 sentences. Hard is 1 sentence. Understood how to find term frequency as well as inverse document frequency.
Yes, ma'am.
So these are the different data cleaning steps that you have to remember. Especially when it comes to, now you need to multiply this IDF with this TF. That's TF IDF. So TF IDF in the sense, now each TF should be multiplied with each IDF. So that gives you the overall TF IDF. That's how it converts. We don't do it. We have libraries to do all this. Any questions? All good so far?
Yes, ma'am.
Okay, we'll move on to the implementation then. Open a Google Colab. launch collab.new. Give NLP pre-processing. Yeah. First one, I'll be importing basic libraries like import regular expression, import a string. Yeah. First thing will be performing a basic cleaning. So let's say when you are given with a data, so how do you clean a text? Take some text which includes an URL, emojis. I'm taking take something like this. Don't think I have a chat option to send you. You write whatever you want. You define text, whatever. Make sure you add some HTML tags. All the stuff. Or if you want, just ask a ChatGPT to give combination of all this. It will give you a sentence, take that. Okay. First up, we have to clean a text. To clean text, I'll be passing a text. First step is converting text to a lowercase. I'll just call text.lower. That converts everything to a lowercase. See, all uppercase got converted into a lowercase. That's the first step. You took some text. Okay, next important one. We'll remove all HTML tags. Okay. So it's like common. Once you study, the same thing can be applied for all the text. So I'll call text equals. I'm calling a regular expression which has certain, patterns which helps in cleaning your text data. I'm just calling a sub keyword, sub method, and you have to mention the pattern. So pattern for HTML tags will be R. So everything will be within a tag, right? So, and the pattern is going to be dot asterisk question mark. Okay, and then it has to replace all those HTML tags with empty string and then pass a text. Comma text. Can you see all the HTML tag got removed? All the HTML tag got removed. Done. Then what else we have? We have a URLs, right? www.https. So how do you remove such things? So text equals. So it's re.sub. Regular expression pattern. HTTP slash s plus if it is something like www dot slash s plus if something like this. If this is the pattern HTTPS or www, then it has to removed. How to remove? So we'll be replacing with empty string, comma text. It will remove. It's wrong. Or HTTP. So use one straight line here before www. Yes, remove now. Be careful with the pattern. Be careful with the pattern. Okay. And then you have an emoji, right? Smiley emoji. Let's remove that emoji. So remove emojis. So text equals re.sub. So here the pattern is a cap. So it uses x00 hyphen slash backslash x7. If these are like a standard patterns used to remove emojis, it will be fixed. It will not change. Okay, replace with empty text and then we'll pass a text. So that smiley should be removed. Can you say removed? So it was replacing all empty spaces. So just give one space. Got it. You don't have any punctuations, no? Even exclamatories and all removed. With emojis only it has removed. Okay, let's say I want to remove the punctuations. Like, let's say, for example, you have 220, 2026, within a bracket. So this is removing everything in English. But still, if you want to remove the special characters, you can say text equals re.sub. Just say to include A to Z. Only text should be there. And 0 to 9 number should be there. If you want to remove even a number, don't write like 0 to 9. Slashes. Can you see? as removed, but at the rate is not getting removed now. Okay. Put this within a bracket. Yes, it's removed now. Can you see? All the special characters got removed. All the special characters got removed. Clear? What if there were like any white spaces? How do you remove the white space? This is for special characters. And then to remove the white space, we have a code like text equals re dot sum open bracket /s Can you see whatever spacing was that before hello got removed? This is what we call it like empty space or a white space. Empty space or a white space. Got it? How to clean any text? Understood. Done till here?
Yes, ma'am.
Next one. Tokenization. For tokenization, I'll be using a library called as an NLTK. So first you have to import NLTK and NLTK.download all the libraries. Then we'll just import a sentence tokenization and word tokenization. First import NLTK and then NLTK dot download. If you see download all, it will download all the libraries. Okay. Otherwise, like it will throw an error for using certain things. So by the time it downloads, we will just install from NLTK dot tokenize, import, word tokenize as well as a sentence tokenize. Imported.
Yes, done, ma'am.
So take a text. I like NLP. So call your word recognize. She got a word recognize. A text got converted into a list of words. A text got converted into a list of words. Same way, take some multiple sentences for sentence tokenize. Let's see, I like Python. SQL is easy. ML is interesting. You have multiple words. Call your sentence tokenize. Just pass your text. I like Python, SQL is easy, ML is interesting. This is how the sentence tokenize as well as a word tokenization is going to work. Done. Next one. We'll go for stop words. Stop words are the common words, like how to remove them. So from NLTK dot corpus, just import a stop words. From NLTK dot corpus, just import stop words. If you want to see the set of all the stop words, you can just call set of stop words dot words, and you have to mention English stop words. You can see the list of all stop words here. These are the stop words which are a common words, not making any no separate meaning they have. They're just like a connecting words, which just makes your sentence a bit meaningful. But if you use them alone, like it's of no use, right? Then, so I'll just create a word equals word tokenize, and we'll be passing a text. Still, I've not defined a text. So let me define text like NLP is easy and very interesting. Okay, this is a text. I'm just creating word tokenization. I'll be using X for X in words. It gives you a list of words. In this, we have to select if words which are not in stop words. So I'll be just creating a list of stop words. And I'll check if X not in stop words. If it's not a stop word, only then it has to print. So that, it removes all the stop words, only non-stop word will be printed. Like this. Like this. Clear? Hope it's done. It's done. From nldk.stun, just import POTUS demo. And then you have to take a text. I'll be taking this text. You also take like this. Let's create our words first. Word tokenize. Now do we need to do? Yeah. So word tokenize, you'll be passing your text. And then you have to define your POTUS demo, PS sequence. POTUS demo. Done. And then I'll be using X for X in words. So it should be, since we want to find the stem of a word, right? You have to call your PS dot stem of X. Can you see the root form it gave? For playing, it's a play. For play, it plays, it's play only. But for studying, it's giving like a STUDI, which is wrong. Getting Next one. Post tagging, part of speech tagging, you can see. So it's NLP is easy. What is NLP? NLP in the sense like a proper noun. Ease is like a verb, easy. So it has a different namings, okay? Like this. Understand the short forms and full forms. Understood? Any questions? Okay. Then. That's it for today. Remaining we'll do it in our next class. Thank you.